So since our midterm is coming up in about 2 weeks, I thought I would go through and make videos for some of the stuff we did earlier in the year that I didn't make videos from, so anything before October, I think. So this one is going to be on scientific notation, unit, some dimensional analysis. It's going to be pretty quick, because, a lot of the stuff this year builds off of each other. You have to use the old stuff to do the new stuff. So I think, by this point, I think everyone's really strong, but, you never know if maybe you want it explained again a different way, or just want to, make sure you're solid with it before the test. So yeah, I'll get started. And so with scientific notation. And so what scientific notation is, it's when you have only one non-zero digit in front of the decimal place. And then you multiply by 10 to the however many times you move the decimal place. So say an example be 65,000 kilograms, and you move the decimal place 4 times to the left. So it'd be 6.5 times 10 to the 4th. Let's say if you had 0.00065 kilograms, move that 1, 2, 3, 4 times to the right to get -4. So say you have a number greater than 1, that's going to be a positive exponent. Or if you have something with a positive exponent, that number is going to be greater than 1. And then if the number is less than 1, it's going to be negative. And then same for you have a negative exponent, that number is going to be less than 1. So that's all there is to scientific notation. We've used that a lot this year, so I think most people should be pretty good with that. Next I'm going to move on to the units, and really I think I'm just going to go over those prefixes. So those are the main ones, and then this one here is the base one. This, what I'm writing right now, this is what you put the prefix onto. So these stand for, so this capital M stands for mega, and that would be 10 to the 6th. K stands for kilo, 10 to the 3rd. This is that, and it's just 10 to the 0, which would be 1. The lowercase d is deci, which is 10 to the -1. C is centi. Centi, 10 to the -2. M is milli, 10 to the -3. This fun looking Greek letter one that I drew poorly is micro, 10 to the -6. The N is nano, 10 to the -9th, and then the P is pico, 10 to the -12. So they're all basically the letters, the first one. And so basically, this is how you convert between units and stuff. And so how you do conversions is, say you're going from smaller units to larger units. You divide, and then you move the decimal to the left. So say you are going from 221.82 nanograms to decigrams. What you're going to do is, so nano is 10 to the negative 9th, deci is 10 to the negative 1. So the difference between that is 8. So we're going to need to move the decimal 8 places to the left. That's where the decimal place goes, and then just fill in all those little humps with zeros. And that is how many decigrams are in a nanogram. And so that's how you go smaller to larger. If you're going larger to smaller, you multiplying, or you move the decimal to the right. So say we have 21.22 kilograms, and we are going to milligrams. So kilograms is 10 to the 3rd, milli is 10 to the negative 3. The difference between these is 6 places back here on our chart, because you have to go 1, 2, 3, 4, 5, 6. And so we're going to move this decimal 6 places to the right. 1, 2, 4, 5, 6, 7. Oops, I went way too many. Yeah. 1, 2, 3, 4, 5, 6. Yeah, that's where the decimal place goes. Fill in all the little loops with zeros. And that's how many milligrams you have. And I mean, and to make sure your answer makes sense, just kind of think about it. If, for this one you have like 20 nanograms, and decigrams are bigger than nanograms, so you're going to have less decigrams because it's a bigger unit. And then on this one, kilograms are bigger, so it's going to take more milligrams to get the same amount of kilograms. This one, it's going to take less decigrams to get the same amount of milligrams. So that's how you can conceptually kind of make sure your answer makes some sort of sense. Okay, and then the last part of this is going to be dimensional analysis. And so you use dimensional analysis. Oops. So you use it to convert a result from one system of units to another. And maybe if you forgot about dimensional analysis, you'll realize it looks a lot like the mole conversions we've just been doing, and it's basically the same thing, except not using mole to Avogadro's number, we're using, anything else. So the steps, you basically use equivalent statements, and then you just multiply, divide until you get what you want. So an example of this, so a gas travels 5.78 inches up a tube. How far in centimeters? So we want to take the inches, go to centimeters. So we need to know conversion from inches to centimeters. 1 inch is 2.54 centimeters. And so the way that we set this up is you start with the given. Make sure you write the units so you know what you have. You put given over 1, and then you multiply, and then you want to cancel out units. And so when you're doing math and fractions, top times the bottom, cancel out. So we know 1 inch is 2.54 centimeters. So now see our inches cancel out. We're left with centimeters. And then just multiply this and this. And so you do 5.78 times 2.54. And you get 17.7 centimeters. Don't forget about sig figs, which I'll go over in another video, and that's dimensional analysis. So yeah, again, we've been using a lot of this all year. It's not like, we did it and then we never came back to it. It's been applicable all year, so this should be just a review. Another reminder about the review session on December 12th at 2, and that's it. Thank you so much.